An amazing trip to Kepler, Earth's twin. Kepler 452b was the first planet of a similar size to Earth found in the habitable zone of its star. The star that this planet orbits is very similar to the Sun, so it's highly likely that this planet contains water and even living things. Will this planet be the future home of the human race? Let's find out. In 2015, NASA's Kepler mission confirmed the existence of the first Earth-sized planet in the habitable zone around a Sun-like star. This was designated Kepler 452b. In the year of the 20th anniversary of the discovery that showed that other suns harbor planets, the Kepler Exoplanet Explorer Space Telescope discovered a planet and a star that closely resembles Earth and our Sun. This exciting result brings us closer to finding an Earth 2.0, where the human race can live. Kepler 452b has a diameter 60% larger than Earth and is considered a super-Earth-type planet. While their mass and composition have yet to be determined, previous research suggests that planets the size of Kepler 452b have a good chance of being rocky. While Kepler 452b is bigger than Earth, its 385-day orbit around its star is only 5% longer than our planet's. The planet is 5% farther from its parent star than Earth from the Sun. The planet Kepler 452b orbits the star Kepler 452 is about 6 billion years old, 1.5 billion years older than our Sun, has the same temperature, is about 20% brighter, and has a diameter 10% larger. We can think of Kepler 452b as an older and larger cousin of Earth, providing an opportunity to understand and reflect on Earth's evolving environment. It is impressive that this planet has spent 6 billion years in the habitable zone of its star, considering that it took only a few million years for the first living beings to emerge on Earth. In case on this planet there are all the ingredients and conditions necessary for life like those on Earth, the chances of it having a life are very high. To help confirm the finding and better determine the properties of the Kepler 452 system, the team conducted ground-based observations at the University of Texas McDonald Observatory at Austin, the Fred Lawrence Whipple Observatory in Mount Hopkins, Arizona, and the W.M. Keck Observatory atop Mauna Kea in Hawaii. These measurements were essential for the researchers to confirm the planetary nature of Kepler 452b, refine the size and brightness of its host star, and better determine the planet's size and orbit. The Kepler 452 system is located 1,400 light-years away in the constellation Cygnus. It's not the closest star system, but it is the closest thing to ours that has been found to date. In addition to confirming Kepler 452b, the Kepler team has increased the number of new exoplanet candidates from their analysis of observations made between May 2009 and May of 2013, bringing the number of planet candidates detected by the Kepler mission to 4,696. The other candidates require observations and follow-up analysis to verify that they are real planets. 12 of the new planet candidates have diameters between 1 and twice that of Earth and orbit in their star's habitable zone. Of these, 9 orbit stars are similar to our Sun in size and temperature. So far, we have fully automated the process of identifying planet candidates, which means that it is finally possible to evaluate every transit signal across the Kepler dataset quickly and uniformly. This gives astronomers a statistically robust population of planet candidates to accurately determine the number of minors, possibly rocky Earth-like planets in our galaxy, the Milky Way. The weirdness of normal. During the Kepler Space Telescope mission, something that caught the attention of astronomers was that they had found an enormous number of compact, multiple planetary systems. Before Kepler's launch, we knew very little about star systems, and most thought that the rest of the solar systems in the galaxy should be similar to our own. Nothing could be further from the truth. When Kepler began conducting information, no one predicted that something like the Kepler-11 star system would be detected, which contains 5 planets and most of them in orbits more minor than the orbit of Mercury, and the outermost of which would fall into the orbit of Venus. For the system, Kepler-186f was announced in April of 2014, an exoplanet with a terrestrial radius of 1.2 in the habitable zone of a small star, only half the size and mass of the Sun. All the planets in that system, including Kepler-186f, which is the outermost, are in a closer orbit than Mercury is. It was astonishing how many planets were in those star systems, especially planets compacted into tiny regions. Everything indicates that nature loves to build planetary systems and that there are processes within these planetary systems that force the planets to migrate inward. Many of these systems are dynamically packaged and coupled so that their orbits influence others. Our solar system, by comparison, seems to be a weirdo in the sense that the planets are pretty scattered. Because of this, it's tough to detect all the planets in a system like ours. It would take many years and the fortuitous alignments of all orbits. So we must understand where our solar system is located in the context of everything else. Although our solar system is normal for us, it is stranger when we compare it to the rest of the universe's solar systems. Because of this, none of the methodologies we have to find planets would allow us to very safely find other solar systems precisely like ours, since ours is especially rare. Could Kepler-452b be the future home of humanity? Kepler-452b may represent an end in more ways to one, being an outcome of the Kepler mission in any biosphere that the distant world may harbor. The planet's host star is estimated to be 1.5 billion years older than our Sun, and the planet itself receives 10% more starlight than our world. Because sun-like stars gradually increase in luminosity as they age, this could mean that Kepler-452b is an old world that slowly fades away. Once thrived alive, but now withers under the intense light of its star. If the planet has only one landmass, any life there could be near its end. The world would be on the verge of a runaway greenhouse effect, with gravity too weak to prevent life-giving water from boiling due to rising surface temperatures. Something similar to what happens in our sidereal neighbor Venus. On this planet, temperatures always remain above 847 degrees Fahrenheit or 453 degrees Celsius, because it is covered by a dense atmosphere of carbon dioxide and its clouds are sulfuric acid. This causes a lasting greenhouse effect that traps heat and heats the planet permanently. Astronomer Douglas Caldwell of the SETI project says Kepler-452b is more likely to be about 5 times more massive than Earth, giving it enough gravity to retain its water and maintain a flourishing biosphere. The planet could have a thick atmosphere with a lot of water, either in the atmosphere, in the oceans, or both, Caldwell says. Given the larger size and the longer core cooling time, we believe that there would probably still be volcanism and therefore high probabilities of developing living things. All of that together would give any robust biosphere on the planet another 500 million years of life, about the same amount of time our planet may have before it starts losing its oceans when the sun starts to die as well. Of course, these are all speculations based on our current data. Astronomers remain skeptical. It is not possible to claim or deny that there is life in Kepler-452b, or that this may be the future home of humanity. The only sure thing is that so far, this is the most Earth-like planet we have found, and it is worth studying since understanding this world better, we will know better what will happen to the Earth in the future to come. Do you think Kepler-452b could have water and living things? Let us know your opinion in the comments of this video.